So in today's video we're going to see chapter 3, that's nothing but inverse trigonometric functions. Okay, so under this inverse trigonometric functions, the first one we are going to see here is inverse of a sine function here. Okay, so here inverse of a sine function, first of all I have written what is sine from the real to minus 1 comma 1. So you know in this case what is this one actually here, it's nothing but your domain, and here if you see this will be nothing but your range. This you would have studied it already here, the domain and the range here. So when you draw a sine curve, okay, whichever gives you minus sine 0, what will you get here? 0. Next is what? Sine pi by 2. What is sine pi by 2? That's nothing but 1. Next is what? Sine pi. What will you get here? It will be nothing but equal to 0. Next is what? Sine 3 pi by 2. That's nothing but equal to minus 1. Here again sine 2 pi. It's nothing but 0. So here if you see it oscillates between minus 1 and plus 1. Okay, so here if you see you have it as same way you have it here also, it is 0. Here again in this case it's here minus pi by 2, that will be minus 1. Here again you will have minus 3 pi by 2, that's nothing but equal to 1. So here if you see it oscillates between minus 1 to plus 1. This is what you get here. Got it? So here I have written it as your sine is from minus pi by 2 to pi by 2. That's nothing but minus 1 comma 1 here. Okay, so the range will be nothing but minus 1 comma 1, between minus 1 and 1, closed interval minus 1 and 1. Why I write it as closed interval? Because minus 1 is also included and 1 is also included. Okay, so here if you have the inverse of this, what is your sine inverse of this one? Sine inverse of minus 1 comma 1 to minus pi by 2 comma pi by 2. Okay, so here I will write, so here if you see here, if I get y is equal to sine inverse of x here, then you can write if and only if, what is that here? Your x is equal to sine y. Okay, so here x is equal to sine y. So this is nothing but the inverse function here. So principal value branch is nothing but equal to your closed interval minus pi by 2 comma pi by 2. Got it? Okay, so your domain is nothing but for an inverse trigonometric function. If you see your domain is minus 1 comma 1 and your range is nothing but equal to minus pi by 2 comma pi by 2. So here this is the first one. Now the next one is the inverse cosine function. So again a cosine function, I define it as a function from r to minus 1 comma 1. Your domain is nothing but the set of all real numbers, and here you have it as minus 1 comma 1 in this case. Now here we'll draw the cosine curve here. So when we draw the cosine curve, you know cos 0. What is your cos 0? It is 1. Cos 0 is 1. What is cos pi by 2? Cos pi by 2 is 0. What is cos pi? It's nothing but minus 1. What is cos 3 pi by 2? Here again it is 0. Here again cos 2 pi, that will be nothing but 1 actually here. So here if you see it oscillates between 0 and here what will I get here? It's nothing but 1. So here what is that you get here? Cos of what will I get here? 0 comma pi. Here in this case you have it as cos pi is nothing but minus 1. Here again the left hand side if you see here it's minus pi by 2. Cos of minus pi by 2 is what? 0. Here again you will have it as minus 1. Here again, sorry, plus 1 you have it here, etc. It goes on actually here. Okay, so here this is what you have here. Got it? Minus 1. Here again it is 0. Here again it's plus 1. So here this is how you have here. Got it? So what is your cos of 0 comma pi? Why I write it as closed interval 0 comma pi actually here? Between the 0 and pi, this is nothing but 1. Here if you see you have it as minus 1. So I can have it as from 0 comma pi to minus 1 comma 1. So what is the inverse trigonometric function you get here? Cos inverse of minus 1 comma 1 to 0 comma pi. The inverse you have here. So what is the principal value branch you get here? That's nothing but 0 comma pi. So what is the domain you have here? Minus 1 comma 1, and your range is nothing but equal to 0 comma pi. So domain is minus 1 comma 1 and range is equal to 0 comma pi. This is what you get here. So like that we have for all inverse trigonometric functions. So the basic one is for sine inverse and cos inverse you need to know here. So I have written it as a table function. Sine inverse, what is the domain? Minus 1 comma 1 to okay, what is the range here? Minus pi by 2 to pi by 2. Okay, and also this is nothing but your principal value also. Okay, so here the principal value branch, that also will be nothing but minus pi by 2 comma pi by 2. Cos inverse, domain is minus 1 comma 1, you have it as 0 comma pi. What is your tan inverse here? It's a set of all real numbers, so domain. So that also, you know your tan, it's nothing but sine by cos. Okay, so denominator whatever you have, suppose if it is going to be cos whatever it is cos pi by 2 or anything like that, it will be nothing but 0. So I cannot take for cos, I'll have to take only for sine. So what is that you have for sine here? It's only minus 1 comma 1. It's nothing but minus pi by 2 comma pi by 2. So you will have it as minus pi by 2 comma pi by 2. That is your range. Similarly, your cot. So what is your cot actually here? It's nothing but cos by sine. So for cos, what is the range you get here? 0 comma pi. So cot inverse, it's nothing but r, and here you have it as 0 comma pi. Got it? The next one is cosecant inverse. So for cosecant inverse, what is your domain you get here? It is r minus of minus 1 comma 1 you get here. That is the real line omitting this one here, because what is your cosecant here? It's nothing but 1 by sine. That is your cosecant you have here. Open interval minus 1 comma 1. That is your minus 1 and 1 are not included here. So what will be the range in this case? Minus pi by 2 comma pi by 2 minus 0. Why is that you write here? Because if I put it as sine or minus 0, because if I have sine 0, what is sine 0? That's nothing but 1 by 0. That is not defined here. So omitting 0, okay, because minus pi by 2 to pi by 2, in between you have 0. So omitting 0, the other interval, okay, you have it as the range here, minus pi by 2 comma pi by 2. Next is secant inverse. What is your domain here? R minus of minus 1 comma 1, or it will be the closed interval 0 comma pi minus pi by 2. This is what you get here, 0 comma pi minus pi by 2. Why I omit pi by 2? Because your secant can be written as 1 by cos. What is cos pi by 2 here? It's nothing but equal to 0. So if I have 1 by 0, it will not be defined. So 0 comma pi minus what will I get here? It's nothing but pi by 2. So this is your range and the principal value branch. So this is what you will have to remember for the problems here. Okay. So in short, I have summarized this as in this diagram here. See here, in this case, I have the thing here, quadrant 0, pi by 2, pi, and here you have it as minus pi by 2. So here, from minus pi by 2, in the anti-clockwise direction only, generally we measure here, from minus pi by 2 to pi. Okay, so from minus pi by 2 to pi, the range is for what all trigonometric functions? Sine inverse, tan inverse. Only for cosecant inverse, you will have minus pi by 2, comma pi by 2, closed interval, minus pi by 2, comma pi by 2, minus what will I get here? 0. Only for this. Okay, so sine inverse, tan inverse and cosecant inverse, your range will be nothing but, or your principal value branch will be nothing but minus pi by 2 comma pi by 2. Okay, so here this is how you will have to remember. Similarly, we'll go over to the next one here. Suppose I have the quadrant 0, pi by 2, pi, and then you have minus pi by 2. Next, what is the range you have here? 0 to pi. So what is the range you have from 0 to pi? Means again from left to right. What all you have? Cos inverse, the first one. Relating to cos, what else you have here? Secant inverse. But secant inverse, there is one thing here, 0 to pi minus what will I get here? Pi by 2. Because in between you have this pi by 2. At pi by 2 you will have, no, the function is not defined. And what else you have here? Cot inverse, because where cot inverse is nothing but cos by sine. So this is how you will have to split and then remember here. First, as I told you, for 0 to pi, it's cos inverse, secant inverse and cot inverse. And from minus pi by 2 to pi, you have it as sine inverse, tan inverse and cosecant inverse. Cosecant inverse and secant inverse alone, you will have to be a little careful. Okay. So exercise 2.1, find the principal value of the following function. So what is the first one? Sine inverse of minus 1 by 2. So I'll have to find out the principal value. So sine inverse of minus 1 by 2. So we write it as y equal to sine inverse of minus 1 by 2. You get sine y to be equal to minus 1 by 2. So in general, you know what is the principal value of sine inverse. Just now I told you principal value of sine inverse is what? Minus pi by 2 to pi by 2 you get closed interval. So you have sine pi by 6 is nothing but equal to 1 by 2 you know here. So what is sine of minus pi by 6? That is also equal to minus 1 by 2. Why I write sine of minus pi by 6? Because sine of minus x is equal to what will I get here? It's nothing but minus sine x. So here you have it as sine of minus pi by 6 is equal to minus pi by 2. So what is the principal value you get here? Your minus pi by 6, it lies in this principal value branch, minus pi by 2, 2 comma pi by 2. So what is the principal value of sine inverse of minus 1 by 2? That is equal to minus pi by 6. Got it? So here this is the first one. Now here coming over to the second one, cos inverse of root 3 by 2. Got it? So cos inverse of root 3 by 2, how do I write it here? Y is equal to cos inverse of root 3 by 2. You will get cos y to be equal to root 3 by 2. So what is the principal value of cos inverse here? It's nothing but 0 to 0 comma pi, closed interval 0 comma pi. So here you have it as cos pi by 6 is nothing but equal to root 3 by 2, you know here. So here in this case your pi by 6, it is in the interval 0 to pi, it is in the interval the principal value branch there. Therefore what can I write? The principal value of cos inverse of root 3 by 2 is nothing but equal to pi by 6. Okay. Now here your third one, cosecant inverse of 2. So what is cosecant inverse of 2 here? Y is equal to, you have it as cosecant inverse of 2. You know cosecant y is nothing but equal to 2 you have here. So what is the principal value of cosecant inverse? It's nothing but closed interval minus pi by 2 comma pi by 2 minus the 0 here. So you know what is sine pi by 6 equal to? What is sine pi by 6 equal to? It is 1 by 2. You know what is 1 by sine pi by 6? What is 1 by sine pi by 6 here? It's nothing but equal to cosecant pi by 6 you get here. So what is cosecant pi by 6? 1 by 1 by 2 you get. That's nothing but equal to 2. So what is your cosecant pi by 6? That is nothing but equal to 2. Okay, so here this is what you have here. So what is your pi by 6? It belongs to the closed interval minus pi by 2 comma pi by 2 minus 0. So it falls in this interval, and therefore the principal value branch of cosecant inverse of 2 is nothing but equal to pi by 6. Got it? Now here the next one, the fourth question, tan inverse of minus root 3. So what is tan inverse of minus root 3? Let y be equal to tan inverse of minus root 3 here. You will get tan y to be equal to minus root 3. So what is the principal value of tan inverse here? It's nothing but minus pi by 2 comma pi by 2. This is the principal value. And you have tan y to be equal to minus root 3. So first of all, we'll find out what gives you root 3 first of all, the positive one. So what will I get here? Your tan pi by 3 is nothing but equal to root 3. And we know tan of minus x is equal to minus tan x. Okay, because I told you sine of minus x is equal to what? Minus sine x, I told you, no? The same way you have it as tan is what? Sine by cos. Therefore this is also equal to minus tan x. So what will I have? Tan of minus pi by 3 is equal to minus root 3. So minus pi by 3, it belongs to the interval minus pi by 2 to comma pi by 2. So what is the principal value of tan inverse of minus root 3? That's nothing but equal to pi by 3. Okay. Now here the fifth question, cos inverse of minus 1 by 2. So what is cos inverse of minus 1 by 2? Let y be equal to cos inverse of minus 1 by 2 you get here. So what is your cos y equal to here? Cos y is equal to minus 1 by 2 you have. So what is the principal value of cos inverse? 0 comma pi. Got it? So 0 comma pi. So you have cos y to be equal to minus 1 by 2. Now my problem here. So we know what is it actually here. First of all, we know cos pi by 3 is equal to 1 by 2 you get. But I need minus cos pi by 3. So minus cos pi by 3. What is your minus cos x equal to actually? Your minus cos x is nothing but equal to cos of pi minus x. This is what you get here. Okay. So here it is cos of pi minus x is nothing but equal to minus cos x. So if I write it as minus cos pi by 3, which is equal to minus 1 by 2, how can I write my minus cos pi by 3? I can write it as cos of pi minus x. What is your x here? It's pi by 3, which is equal to minus 1 by 2. So what is your pi minus 1 pi by 3? That's nothing but cos of 2 pi by 3, which is equal to minus 1 by 2. Now take this 2 pi by 3. Does it belong to the interval 0 comma pi? That's a principal branch. Yeah, it lies in the principal branch there. So the principal value of cos inverse of minus 1 by 2 is nothing but 2 pi by 3. Okay, the next one, the sixth one, tan inverse of minus 1. So what is tan inverse of minus 1 here? We'll have to find the principal value of this. So we'll take let y be equal to tan inverse of minus 1. So you will get tan y to be equal to minus 1. So first, if you have a negative value, always see what is the positive value here. You know that tan pi by 4 is nothing but equal to 1. So here your tan of minus pi by 4, because what is your tan of minus x? It is equal to minus tan x, you know here. So I can write it as tan of minus pi by 4 is equal to minus 1 you get. So what is the principal value of tan inverse? It's nothing but equal to closed interval minus pi by 2 comma pi by 2. This is what you get here. So I can say minus pi by 4, it belongs to the closed interval minus pi by 2 comma pi by 2. So what is the principal value of tan inverse of minus 1? That's nothing but equal to minus pi by 4. Got it? Yes. The seventh question, secant inverse of 2 by root 3. So what is secant inverse of 2 by root 3? Here you will take, let y be equal to secant inverse of 2 by root 3. Taking it to the other side, you will get secant y to be equal to 2 by root 3 you get. So what is the principal value of secant inverse actually here? Your principal value of secant inverse is nothing but equal to 0 comma pi minus pi by 2 you know. So what is the secant actually here? You know what is cos pi by 6? What is cos pi by 6 here? It's root 3 by 2. So what is 1 by cos pi by 6 actually here? 1 by cos pi by 6 is nothing but equal to 2 by root 3. So what will I get here? Secant pi by 6 is nothing but equal to 2 by root 3. So that's what we have written here. Your secant pi by 6 is nothing but equal to 2 by root 3. Now this pi by 6, it must lie in the principal branch 0 comma pi. Yes, it lies in the principal branch 0 comma pi. So I can say that the principal value of secant inverse of 2 by root 3 is nothing but equal to pi by 6. Okay. Now here the 8th question. What's your 8th question? Cot inverse of root 3. So what is cot inverse of root 3? Let y be equal to cot inverse of root 3. Taking it to the other side, you have it as cot y to be equal to root 3 you get. So what is the principal inverse of cot actually here? The same for cos you will get. What is that you had for cos? It's nothing but 0 comma pi. Okay, so here you have it as 0 comma pi. Now, you know what is your tan pi by 6. What is tan pi by 6 equal to? It is equal to 1 by root 3 you will get. What is 1 by tan? That's nothing but cot. So, I can write cot pi by 6 is nothing but equal to root 3 you have. So, here in this case, your cot pi by 6 is equal to root 3. So, your pi by 6, I must see whether it lies in the principal branch here. Yes, it lies in the principal branch 0 comma pi. So what is the principal value of cot inverse of root 3? That's nothing but equal to 0 comma pi. Got it? Yes. Now here the 9th question. Cos inverse of minus 1 by root 2. So what is cos inverse of minus 1 by root 2? Let y be equal to cos inverse of minus 1 by root 2. Now taking it to the other side, you get it as cos y to be equal to minus 1 by root 2. So what is the principal value of cos inverse? It's nothing but 0 comma pi you get here. So what is cos pi by 4 here? Your cos pi by 4 only is equal to 1 by root 2. Always when you have a negative value in the right hand side, first find the positive value, then we'll go. So here we know that your minus cos pi by 4 is equal to minus 1 by root 2. Already I told you your minus cos x can be written as what? Cos of pi minus x. Okay, by using that all silver teacups that what actually are. So cos of pi minus x. So here this minus cos pi by 4 can be written as cos of pi minus your x is what? Pi by 4, which is equal to minus 1 by root 2. So what is cos of pi minus pi by 4? That's nothing but cos 3 pi by 4, which is equal to minus 1 by root 2. Now I'll have to check whether this lies in this principal branch. Your 3 pi by 4. Sure, it lies in the closed interval 0 comma pi. So what can I write here? The principal value of cos inverse of minus 1 by root 2. What is it equal to here? It's nothing but equal to 3 pi by 4. This is the principal value you have here. Okay. The 10th question, cosecant inverse of minus root 2. So what will you get here? Let y be equal to cosecant inverse of minus root 2. So taking it to the other side, you will get it as cosecant y is equal to minus root 2. So what is the principal value of cosecant inverse? It's minus pi by 2 comma pi by 2 minus 0 you get. So here you know what is cosecant. Cosecant is nothing but 1 by sine. Okay. So here if you see, you know, your sine pi by 4, it gives you 1 by root 2 you get here. So what is 1 by sine pi by 4 actually? Or 1 by sine pi by 4 is nothing but equal to root 2 you get here. So 1 by sine is nothing but cosecant. So cosecant pi by 4 is equal to root 2. Now I'll bring the negative sign here. So here in this case, since you know that your sine of minus x is nothing but equal to minus sine x, you know. Got it? The same way it goes for cosecant also. So I can say cosecant of minus pi by 4 is equal to minus root 2. Now see whether it lies in the principal branch. Minus pi by 4, it belongs to the closed interval minus pi by 2 comma pi by 2 minus 0 you get. So what is the principal value of cosecant inverse of minus root 2? That's nothing but equal to minus pi by 4. Okay. Now the 11th question. So here it's like the previous one, but you have sum of inverse trigonometric functions. That's the only difference you get. So tan inverse of 1 plus cos inverse of minus 1 by 2 plus sin inverse of minus 1 by 2. So we'll take it separately and then equate it to a variable here, find out and then sum up everything here. So I have taken tan inverse of 1 to be equal to y. So you get tan y to be equal to 1. What's the value of y you get here? Y will be equal to pi by 4. What is the principal branch you get here? Minus pi by 2 comma pi by 2. It belongs. So I can say that your y is equal to pi by 4. Can I say your y is equal to pi by 4? Next, take the next one. Cos inverse of minus 1 by 2 equal to x. So you get cos x to be equal to minus 1 by 2 you have here. So you know, okay, already if you have a negative value, first take with the positive value. Cos pi by 3 is equal to 1 by 2. So you know your minus cos pi by 3 is equal to minus 1 by 2. So what is minus cos x equal to here? I can write it as cos of pi minus x. Can we write it like this? So I will write it as cos of pi minus pi by 3, which is equal to minus 1 by 2. So what is pi minus pi by 3? That's nothing but cos 2 pi by 3, which is equal to minus 1 by 2. Now your 2 pi by 3, does it lie in this principal branch? Yes, it lies in the branch 0 comma pi. Therefore, what is your x equal to 2 pi by 3? So here you have got pi to be equal to pi by 4. Here you have got x is equal to 2 pi by 3. Now you have one more inverse trigonometric function, that we'll take it as z. Z is equal to sine inverse of minus 1 by 2 here. So sine inverse of minus 1 by 2, I can take it as sine z is equal to minus 1 by 2. So if it is sine, not at all a problem, even if you have minus. Because what is sine of minus x equal to? It is equal to minus sine x. So I can write sine of minus pi by 6 to be equal to minus 1 by 2. So what is the principal branch you get? Minus pi by 2 comma pi by 2. So minus pi by 6, it belongs to minus pi by 2 comma pi by 2. So what is your z be equal to here? Minus pi by 6. Got it? So here we'll just sum up everything here. So when you sum up everything, tan inverse of 1 plus cos inverse of minus 1 by 2 plus sine inverse of minus 1 by 2. What is it equal to here? This one is pi by 4. This one is plus 2 pi by 3. This one is nothing but minus pi by 6. Take the LCM, you will get it as 12. So it's 3 pi plus 8 pi minus 2 pi. So what's the answer? You get 9 pi by 12, which is equal to 3 pi by 4. The 12th question, cos inverse of 1 by 2 plus 2 into sine inverse of 1 by 2. So first we'll take, let cos inverse of 1 by 2 be equal to y. You will get cos y to be equal to 1 by 2. So what is 1 by 2 there? Cos 60 is equal to 1 by 2. So you can take cos pi by 3 is nothing but equal to 1 by 2. So what is the value of y you get here? It's equal to pi by 3. Your pi by 3, does it belong to the principal branch of cos inverse? It's nothing but 0 comma y. It belongs there. So I can write it as y to be equal to pi by 3. Now the next one, take x to be equal to sine inverse of 2. So you will get sine x to be equal to 1 by 2. So you have sine pi by 6 or sine 30 is nothing but equal to 1 by 2. So does it belong to the principal branch? Yes, pi by 6 belongs to minus pi by 2 comma pi by 2. So what is the value of x here? X is equal to pi by 6. So you will get cos inverse of 1 by 2 plus 2 into sine inverse of 1 by 2 is equal to pi by 3 plus 2 into pi by 6. So here it gets cancelled. Pi by 3 plus pi by 3. What is it equal to here? 2 pi by 3.